Everybody can hear me? Okay. So the sound's better, right? Because now I'm using the mic so that the voice can be captured a bit clearer, right? Yeah, regarding the archive video section, Tian, sorry, I forgot to actually make it as a sharing folder. So that's why you got the link, but you cannot access so far. But actually, I set it to the sharing mode already, so you can actually build the archive section if you want to review what we have done previously in the previous lecture. So you can just turn it back and review again. Okay. So yeah. So same case with Yeta. Okay. Now let's proceed. Today we are not going to touch with the tutorial so far because for the first questions, first few tutorial questions, the theory part we haven't covered yet. So that's why we try to spend 1 hour for the lecture today, right? And then follow up, we're going to see some of the tutorial questions, how you're going to cope with those questions in case we wanted to see how is the problem look like. Okay, 19%. We still have another 2%. Okay, 20. Another one student left. Okay, then we proceed a bit about the theory part. Okay, now before we proceed, just a little bit with the spot checks from you guys, all right? So make sure you have done the revision. Yeah, Alvin, I would like to ask you the first questions. What do you know about the communication?
Pardon, sir?
What do you know about communication?
Something about to connect something.
Yeah.
Something.
Okay. So when you are connecting with somebody, that is what we are dealing with, the communication. Okay, very good. Anna, what do you know about electronic communication? Anna, you still there? Hello.
Let me think first.
Oh, you lay your team first. So how long you're going to think about it?
You asked me for physical electronic system or
electronic communication. What do you know about electronic communication? Electronic communication and the communication slightly different, right? So what is the key thing about the electronic communication? How you define it? The most important part?
Using electric device.
Yeah, you have electronic devices will be used for this communication process, right? So that is the key thing about it. But in terms of the definition, remember, the electronic communication basically is deal with the process that you are going to transmit, receive, and proper processing of the information by using the electronic circuit or the devices, right? So in case you want to answer the questions such as the define electronic communication, it's very crucial that you have to give the proper definition, right? So your answer should not be too long, but should be precise enough. So you have to speak up your the key point about it. Okay, so also in the last section, actually we've been discussed about the types of the electronic communication, right? So how we actually categorize the electronic communication. Somebody? How are we going to classify the electronic communication in terms of
analog and digital?
Yeah, analog and digital. This is the first way. And the other way? Simplex. Yeah, we have a simplex and duplex. So good. So another way is actually we haven't discussed yet. Yes, in the previous section, we haven't finished yet. Is the one we are talking about, the baseband and modulated band. All right. So today I'm going to proceed with the baseband communication and the modulated band communication. Okay. Now to understand about the baseband and modulated band, right? So we are talking about the frequency of the signal. Let's say you have a signal. You want to perform the communication. You want to send your signal to somebody else, right? So in case your signal actually is the original signal without processing, without changing in terms of the frequency, then we will call it as a baseband signal. And this signal, you can use any devices. You send the signal through the receiver. Now, what I'm trying to tell you here is, let's say we have person A, and then we have a person B. Now, if I try to capture the mic, capture the voice by using the mic, and then my voice signal will be captured by mic here from the person A, and then there will be the cable connected to the person B there. And then at the person B, we try to play back the sound. And then person B can hear what is my voice signal. Now you can see that for this case here, my voice signal is the analog form. So basically this signal will be in terms of low frequency, right? So how is the signal low light? This is the signal in analog form. This is the signal in time domain. Now, if you are talking about the signal in frequency domain, my signal here, it can be represented by this one, right? So this is a signal represented in frequency domain. So what is the frequency here? So basically is 3400 Hertz. And then what is the lower limit of my voice signal? Will be somewhere around 300 Hertz, right? So if you come up with a voice, so normally the voice signal, the sound from yourself will be ranging from 300 until 3,400 Hertz. How is the signal low light? This is a signal low light in time domain. Is it clear enough? Okay, so my signal if I capture by using the mic in time domain, this is the one it should be look like. However, if we look at the signal in frequency domain, my signal shall be look like this one. So from the frequency domain of the signal, I can see the lower limit of the frequency for the signal. I can see the upper frequency limit for my signal. So it's ranging, hold on, it's ranging from 300 until 3,400 hertz, right? So we have our questions come from given, is the human voice frequency still the same even when we are singing? That is a good question. Now, when you are singing, your frequency of the singing is still ranging from 300 until 3,400, all right? So frequency of the human beings cannot be changed, right? Unless you are talking about the male and female. Male, normally the frequency for the upper limit will be lower than female. So that's why you can see that the female, if they capture the voice signal, the frequency for the female, especially the obasan. So you can hear that the signal frequency is much higher, all right? So there is a difference between the male and female. However, if you are talking about the music, all right? So music and the human voice, the frequency would be much more different. So normally the music, the frequency will be go much higher until few tens, maybe 20 kilohertz or 50 kilohertz or much higher, right? But for the human beings, no matter how, unless you are the Superman, then your frequency can go beyond than this one. So for the normal humans, the maximum frequency of your voice signal is 3,400. Is it clear enough? Okay, now what is the point here is I want to show you that, in fact, if you are talking about the communication for the baseband, in this case, it means that the signal for communication to be transferred will be original form of the frequency. For example, by using the mic, this is a signal I capture. Then I transmit this signal directly to person B. All right, so this type of the communication, we call it as a baseband communication. All right, so baseband frequency, this is a 1. Now, however, there is the kind of the communication whereby we have a person A. So in this case here, we have the person A speak out from the mic, and then there will be the device we call modulator. And then you're going to transmit the signal wirelessly to another person far away from you. And then we will have the modulator from the other side, or we call it as a receiver, and this side will be the transmitter. Then you're going to play back the sound from the another side. Then the person B can hear what I'm talking about, right? So you can see this one, we have a difference between this one and this one. This one we call it as the baseband communication. And this one, we call it as a modulated band communication, right? So see the difference. This one, the baseband communication, basically it indicated the signal you use for the transmission is actually the original form without changing. How is the frequency look like? This is a 1. However, if we are talking about changing of this frequency to something higher by using the modulation process, for example, this one, then we will call it as a modulated band communication. All right. So how is the signal look like for the modulated band signal? So this is the one actually we are talking about. Right. So this is a baseband. The frequency is lower. This is the modulated band whereby the frequency is much more higher. Right. So there is a difference between two types of the communication here. Now, you might come up with the question, why we have a baseband, why we have a modulated band communication. Now, baseband communication, you can see that we are talking about the original form of the signal without processing it. So it means that your voice signal, this is a frequency. My voice signal, this is your frequency as well. All right? So everybody actually, we are having the same range of the frequency for the voice signal. So if, just imagine, if in the class, one person speaking, so you can hear the sound. If two persons speaking in the class, there might be the interference, right? So you cannot hear clearly what is the information is, right? So if you have more people speaking in the class, so actually we will say that there will be the noise already, right? Your signal in terms of the frequency overlap means there will be the interference, right? So if the communication you have an interference, it will be the serious problem. So in order to solve the problem, well, we are using the modulation process to help us, right? So how we do it so is that this is a baseband. My signal, let's say I'm the first one. Okay, so from the baseband signal, I transform it to the modulated band signal. So I will be here. This is my voice signal. Now let's say there is the second person, Jian, speaking. So this is a range of the frequency Jian got. But after the modulation process, we're going to bring the frequency of Jian from the low frequency to somewhere higher. Right? So you can see that the signal for me and the Jian actually is different range after the modulation process. Right? So by doing so, we will not be having any interference for the voice signal for the communication. All right? So this is the reason why we have modulated band, why we have a modulation to be used in our communication. Is it clear enough? Okay, Okay, now the second reason why we use the modulation is because here I want to emphasize why we use the modulation, why we deal with the modulated band communication. The reason is because for the short distance, there should not be any problem by using the baseband communication. By using the wire, you can connect and transfer your voice signal from one place to another place without any problem. But if the distance between them is getting larger, then we might have the problem to send the signal in between. All right. So in order to solve the problem, what we are going to do here is we are using the modulation. By using the modulation, signal can be controlled and adjusted to be sent for longer distance. This is the first one. Now, the second one, by using the modulation, we can actually select the frequency we're going to produce for the modulated signal. All right? So, which means my voice signal will be translated to become the modulated signal with the frequency which we can choose. For example, just now we show you that I can select my frequency to be placed to the higher frequency range, or here, so that we won't have any interference. All right. So in this case here, means that the frequency for the communication in this case here can be adjusted. Why we need to do it in this way? Later I'm going to explain it in terms of the size of the antenna design. Now, in order to do the wireless, so you need to deal with the length of the antenna. And then the antennas, the length of the antenna is really depends on your signal frequency. Signal frequency go higher, then the length, the wavelength, it will go shorter. And then the size of the antenna become smaller. Then it will be manageable. Okay, so I repeat again. So this one, actually, we are, why we do the modulation, the reason is because we want to adjust the size of the antenna. For the low frequency signal, the size of the antenna required will be very, very long or big. All right, so that's why we need to perform the modulation in such a way that when we transmit the signal, the length of the antenna design can be manageable. So how we do it is by using the signal frequency. We adjust the frequency to higher frequency so that the wavelength can be lower, and then the wavelength, we will use it to design the size of the antenna. So smaller wavelength, the smaller of the antenna, the better of your design for the antenna. Okay, so just now we have one question from our students. Is it meaning to say that the modulator is separating the frequency instead of a frequency in one place? Yes. In this case, actually, we try to use a modulator so that the signal to be transmitted will be separate range. Instead of for everything, it comes with the frequency 300 until 3,400. Correct. All right. Now, actually, the modulation actually is quite complicated topic. Sometimes it will be interrelated with a lot of parameters. All right. So we will go through the things here one by one later on. Okay. So basically, for the baseband signal, this is what we are talking about. So let's say you have a human being, you use a mic, and then the mic, the signal capture, so you will see something analog signal by using the oscilloscope. However, by using the spectrum analyzer, you're going to see the signal in frequency domain. So this one is a time domain. This is a frequency domain. So that's why here you can see a lot of time I try to explain about the signal. Some signal actually I talk it in the time domain, and some signal actually I talk it in frequency domain. So you have to know about the relationship between the signal in terms of the time domain and the frequency domain. So this one, I shall believe that you have gone through the signal assistant. That would not be the big issue for that. All right. Okay. Now, just now we are talking about your communication. Either it's a passband and modulated band. So actually, it's very easy. We can see the difference between them. Okay. Now, just now we are talking about the very important thing about the modulation. So basically, the modulation is a process that we translate our signal from the low frequency to the high frequency. So this signal is a high frequency. If you receive this signal, you cannot hear anything because the frequency is higher. Your ear actually will have a limitation. They only can sense the frequency up to about 10 kilohertz. Higher than that, you cannot hear. So this one is talking about few megahertz of the frequency signal. So that's why you hear, when you receive this signal, you cannot hear anything. So that's why you need to have another process called demodulator to bring the high frequency signal back to the low frequency signal when you receive the signal at the other side. So it means that this side actually is modulator actually is on the transmitter side. You transmit the signal for longer distance. And at the receiver, after you receive the signal for the long distance, then we're going to perform the another process called demodulator to convert the signal from this to this, right? And this signal, finally, you can hear what is your sound or the signal, voice signal, right? So see the difference, modulator and demodulator, actually they are the brothers, right? So you convert it from low frequency to the high frequency, and then you use a demodulator to bring the frequency back to the lower, right? So we have a modulation and demodulation process. Now, one thing I want to emphasize here is basically the modulator, we're going to play with your modulating signal. Modulating signal, sometimes we call it as an intelligence, which is the information you want to transmit or the original information you want to transmit. Okay, so basically for the modulation process, we have original signal you want to transmit, right? So inside the circuit of the modulator, what do we have? You have the device here we call meter. All right, so meter, what is that meter? We're going to discuss it next sections, all right? So basically, this is a device that they are going to combine the two signals. One signal is the original signal you want to transmit. The another signal actually is so-called carrier, all right? So when you combine these two signals, then the modulated band signal will be produced. And this signal is more suitable to be transmitted for longer distance. So mainly this signal is for communication purpose. All right. So when the receiver, they receive this signal, they try to be received by the receiver, and the receiver there will be the demodulator to bring the signal back to the lower frequency. All right. So there is a simple idea or the broad diagram of the modulation process. Okay, now here I will go through a bit faster because just now we have explained the holding of the communication in terms of the transmitter, receiver, and also transmitting medium. Transmitting medium actually is referred to the cable, or if there is a wireless, then the A will be your transmission medium. All right, so we will go through the things here quickly in this case. Now, if you look at the communication system block diagram, so you can see that we have three elements here. So first one is the transmitter. It's the part that you capture your voice signal and then perform the modulation process. You amplify the signal so that the signal can be transmitted for longer distance. All right. So after you transmit your signal, the signal will be traveling all the way to the receiver. At the receiver, remember just now, the very important part at the receiver there is the demodulator. Why we need to have a demodulator? Because the signal need to bring down from the high frequency to the lower frequency upon the receipt of your signal from the long distance transmission. All right. So in brief, we will have the transmitter. You will have the receiver. All right. So at the transmitter, you have a modulator, whereby they get the two input signal here. First one is the information you want to transmit, low frequency. The other one is a high frequency carrier. So you use these two signals, modulate it, and then become the modulated signal. In order to let the signal to be transmitted for longer distance, your signal here should be amplified. So that's why there will be the amplifier here, so that the signal can send for longer distance and received by the receiver. At the receiver, we amplify the signal again because the signal have gone through the long distance. You need to amplify so that it can sense the signal to be received. Then after that, they perform the demodulator, or sometimes we call it as a detector. Then we amplify the signal so that it will drive the speaker at the side there. You can hear the voice, all right? So basically, output of your demodulator is your original signal you transmit already. So you can see the intelligent here and intelligent here. Basically, they are the same signal. All right. So what actually we explained just now, you can see the things here at the slide here at the back. All right. So in terms of the transmitter, you have a transducer. Basically, it's referred to the mic. You capture your voice signal, convert it to become the electrical signal. So this signal we need to amplify because the signal might be too weak for processing, right? Then after that, we have a low frequency signal will be produced here, right? And the another signal will be required will be the carrier. It's actually referred to the high frequency signal for the modulation process. So how high actually is the frequency for the modulation? So typically will be in range of megahertz. So this one we are going to see the summary of the frequency spectrum later on to see that what are the range of the frequency will be suitable for the communication and the modulation process. Okay, so later on we're going to see in some more detail. Okay, so just now we have, we have some more questions. Can we use the term amplify the frequency for the function of modulator? The answer is no, right? So we have a question asking, can we say the modulator, the function is amplify the frequency? No, we can say that the modulator actually is translate your frequency of the signal. That should be okay, not amplify, all right? So amplify only applicable in terms of the signal amplitude, right? So that means the signal is larger or smaller, but in terms of the frequency, you cannot use amplify, okay? Another question is, I think the main function of the modulator is conversions instead of the amplifying. Yes, that is a correct definition. we use a modulation, actually is a conversion. That means the translate your frequency from the lower to the higher or higher to the lower, all right? So another word you can use in this case here is the conversion. That should be okay, right? So modulate means the change something and make it suitable for its duration. And I think the Kevin is right. Okay, very good. All right. Sorry, just now I see the message a bit late. All right. So the another side is this is an explanation about the transmitter and the explanation. So you can look it clearly about it. All right. So until here, and okay, if there is the need of the amplifier, does it mean that the modulating process will result in frequency loss? Okay, Kevin, first, in order to answer your question, first I need to ask you, what do we mean by the frequency loss? Yeah, Kevin? What do you know about the frequency loss? The amplitude of your signal or the frequency? Frequency never can be weakened by or lower by themselves. All right. Now, what I'm trying to tell you here is, if you are talking about your signal amplitude, so in terms of the time domain, right? So signal, it will be something like this. It can be something like this. Now, compare between the two signals, right? Compare between these two signals, you can see that my signal actually will be the same. The only difference between these two signals here is in terms of the amplitude is getting lower. Why lower? The reason is because if you transmit your signal for long distance, now of course, the amplitude of your signal will get attenuated. So attenuated means the amplitude of your signal getting lower. But in this case here, the frequency of your signal never change. All right? Is it clear? So basically for the communication system, when you transmit the signal, the frequency, it never change with the distance. So if you transmit the signal at the receiver side, when you receive the signal, what the change is only the amplitude for the signal, but the frequency is still remain the same. Okay, right, very good question. I know a lot of students, when they deal with the time domain and the frequency domain, amplitude and the frequency, so sometimes it might be confusing, right? So never mind. We will try to go through the things here one by one again. Then we see how is the thing related from one and another. Okay, so very good question. So I need to pay attention on the whiteboard there. So I will come up with the question. All right. Okay. Now we go through this part again. This is very important. Now this one we are talking about the modulation process. All right. So just now we seen that the modulation process, we have two signals. One is the baseband, another one is a carrier signal. So this one is a low frequency signal, not suitable for long distance transmission. And another reason here is if you transmit this signal directly, the another person also transmit this signal directly, then there will be the interference. So in order to solve the problem, so we will use the modulator here. So modulator perform the modulation. Basically, it will try to bring the low frequency signal, which is the signal you want to transmit, to something higher, so that the interference, it won't be happen. And secondly, just now we have mentioned that for the low frequency signal, not really efficient for signal transmission. So you need to bring the low frequency signal to the higher, so that the size of the antenna for the communication can be manageable. Okay, so in order to answer the question here, this is a one. Okay, so popular question, it might be asking about it. So what is the problem with the communication? So we are talking about the problem of the communication in this case here, right? So what is the problem? So the main problem here, we have two. So first one is the interference. Another one is the antenna design, right? So just now we mentioned that we need to have a modulation because we want to reduce the interference problem, because everybody occupies the same range of the frequency. For example, the voice signal, you, me, the frequency range will be the same. When we combine it together, there will be the interference, right? And second reason is because the size of the antenna is a question, right? So in order to transmit your signal, then the size of the antenna is depend on the lambda. So what is the lambda? Lambda is depend on my frequency of the signal you want to transmit. So in order to transmit your signal by using the antenna, because you're dealing with the wireless, the frequency you need to get higher. When the signal frequency is higher, then the lambda is getting lower. When the lambda is lower, normally the antenna design, the size is depend on the lambda of the signal you deal with it. All right. So that's mean in this case here, the size of the antenna is really depends on the signal you transmit. So in order to make your size of the antenna to be smaller, to be manageable, you need to increase the frequency of the signal to be transmitted. So in order to do so, you need to go for modulation process. Okay? Right, now, there will be the question. How do we know that the frequency go higher, the lambda go lower? What is the lambda actually? Anybody? Wavelength. Right, very good. Okay, now if you are talking about your signal, so sinusoidal, let's say. So in this case here, we have a time period t. Other than that, we have parameter about the amplitude, correct? And other than that, we have a phase angle. What we didn't show you on the diagram, okay? So this one is t, and then the period t, we can get it here, and then this one is related to my frequency, and then this one is related to the amplitude of your signal. What actually we didn't show you in detail here is the wavelength. So what do we mean by the wavelength? Now, wavelength actually is, you just imagine the waveform here will be exist in the space. So this one is in terms of the time, right? So if we are talking about in the space, so let's say you have a person here, you have another person here, then you will see the wavelength of your signal, something like this, right? So this is talking about the real distance between the first peak and the second peak. So the peak for one cycle, the distance, we are calling as the wavelength. So that means the length of the wavelength for one cycle, right? So see the difference. This one is talking about one period, the time you complete for one cycle, the time taken, right? So we call it as a period. But if you are talking about the space, time space, well, we are talking about Albert Einstein, right? So if you are talking about the space, let's say we have a person A and B, so you can see the wavelength of your signal up and down like this. So you will see the first peak and then go down and return, right? So means that this one is one cycle. So the distance between the first peak and the second peak, we can define it as the wavelength, right? So from there, we will get the wavelength. Okay, now in order to relate your frequency and the wavelength, so we still remember that previously in your physics, you are talking about the wave propagation, right? So for example, the voice, the light in form of the electromagnetic wave, right? And then we have mentioned that the signal will be in terms of this, and then you will have the length of the wave to be measured in one cycle, all right? And then finally, we will have a formula C equal to F lambda, whereby the C is the wave propagation speed, will be in terms of 3.0 times 10 power 8 meter per second. So means that when we come up with the wave, either is the electromagnetic wave, the voice, electromagnetic wave. So we are talking about the same thing, right? So wave propagation will be talking about the speed here, right? So if you know the speed of the wave propagation, when you come up with the wireless, it means the EMF wave, right? So we can use the formula here to calculate what would be the wavelength if you know the frequency, right? So in this case here, if I know the frequency, I can calculate the wavelength. So in this case here, C actually is a constant. So means that the wavelength actually is inversely proportional to the frequency. Frequency go higher, wavelength go lower. Okay, so that is the one we mentioned just now. Okay, yeah. Is it too far away? Still alive? Okay, right. So for the modulation, we can solve the problem, right? So by actually we are performing the modulation process, whereby the low frequency signal can be translate or convert, become the high frequency. Okay, so by using the high frequency of the modulation process, and then the frequency can be sent it to the higher, and then higher frequency, then we can arrange it in such a way that there will be no interference between one and another. Okay, so the interference can be minimized. Now the another one which we can solve it in this case here is higher frequency by using the modulation process. The size of the antenna can be manageable. Why manageable? So if you try to use a simple calculation, C equal to F lambda. Now if you are talking about the voice signal, voice, let's say is 3 kilohertz. So what is the wavelength should be? Somebody can do the simple calculation for it. So if you have a voice signal, if you want to transmit this voice signal, so what is the size of the wavelength will become out? Nobody? Oh yeah. So remember my C actually is 3.0 times 10 power 8, right? And then the frequency now is talking about 3 kilohertz. So what would be the lambda? So using the formula, tell me what would be the lambda for the case here. Hello. Yeah, somebody come up with 100 kilometer, right? So this 100K, so 100 kilometers. So just imagine if you want to transmit your voice signal, the size of the antenna, how is the size? Then you will come up with 100 kilometers. So how long is the antenna? There is a problem. However, if you try to use the modulation process, let's say you are talking about 3 gigahertz to higher frequency here. So now lambda will be 0.1 meter, right? Okay, so roughly lah. So this is just try to show you that in order to make your size of the antenna to be manageable, you need to come up with the signal to deal with that to be higher. So that's why nowadays you can see that the design of the handphone. Can you see the antenna there? Cannot. So where is the antenna of your handphone? It's actually built inside the PCB board because the distance or size of the antenna can be very short. Okay, so you can build in within the handphone. So why we do so? Because now the frequency to be used by your handphone is getting higher and higher. So higher of the frequency, the shorten of your wavelength. So that's why it will be related to the size of the antenna. So that's why the antenna size is getting shorter and shorter. All right. So this is all interconnected. Okay, so far? All right. So the second part or second element of the communication is talking about the transmission medium. This one we were going to discuss at the end of the semester here, whereby we're going to look at the different type of the communication medium or transmission line analysis. All right. So third element in this case here is talking about the receiver. It's a part that we try to receive the wireless signal. We pick up from that, and then we do the demodulation process. All right. So basically inside the demodulation or demodulators. We have a carrier again to be removed, and then finally left with modulating signal to be recovered. Okay, so roughly this will be the plot diagram to illustrate the typical receiver you're going to have. All right, so very simple idea about the communication system. If you try to explain by using the plot diagram, will be able to explain it easily. Okay, so let's proceed a little bit. So this one, we are talking about the electromagnetic spectrum and allocation. Now, why the electromagnetic spectrum is important to the communication is because when we talk about the communication, typically it will be involved with wireless, right? So wireless means that you're going to use up the frequency. The frequency for this communication process, once you use a frequency, means that the another person cannot use the same frequency in your area or the regions, right? So it means that the frequency resources is limited. So once you use up, then other people cannot use it already. So that's why the electromagnetic spectrum, normally we need to have proper allocation. Now in Malaysia, actually, who is the person to allocate the electromagnetic spectrum, the frequency resources? Anybody know it? Prime Minister Office? No. Somebody? Who manage the electromagnetic spectrum and allocation in Malaysia? No idea. Okay, so the answer is MC, right? So this one is the special agency under the government Ministry of Communication one. They actually manage the allocation of the frequency spectrum. So it means that in Malaysia, who can say you can use the frequency from this range to the another range? So MCNC will have the say, right? And also, this department or agency, they will try to decide in Malaysia which department using certain range of the frequency, which department cannot use, right? For example, the new 5G handphone service is coming out already. The new frequency range is allocated to the operator. So who they are going to have a say that can use the frequency for the communication? So the answer is NCNC. All right. So we have the agency to have a proper allocation of the frequency resources in Malaysia. But in international, so if you are talking about the international, so we have a special union for that, International Telephone and Telegraph Union. So this ITU is the real person to control the allocation of the frequency in the whole world, right? What we have, the NCMC, is follow the framework of the allocation from ITU. But in Malaysia, MCNC, they can do minor modification. Majority is still need to follow the international standard, right? So that's why you can see that you design the radio receiver, right? Your product can be sold to other country. Why? because Malaysia and other country, they are all the ITU member. The device you design in Malaysia actually is compliant with the other people in other country, right? So that is a good thing about the standard, right? So for the detail about the ITU, actually, I'm going to put the appendix in the Google Classroom so that you will look at the electromagnetic spectrum and allocation in Malaysia and the whole world, how is the thing look like, and then you try to get some idea about it. So we are not going to study about the allocation in detail. Basically, it's very tedious and complicated because they basically try to have an allocation of the frequency, and then they try to describe what are the parties or the agency can use the frequencies there. So very boring. If you are interested with it, you can look for it. Okay. So here we try to show you the simple summary about the electromagnetic spectrum and allocation for the typical application. So from this axis, you can see that we have a different band of the band from 3 kilohertz until 30 kilohertz. We design it as a very low frequency. From 30 kilohertz until 300 kilohertz, we call it as a low frequency, medium frequency, high frequency, very high, ultra high, super high, extra high, and don't know how. Okay, so that is the original design and the allocation of the frequency worldwide. So initially they have a name, but until at the end that you will see that they come up with no name. Why? Because after 300 gigahertz, we have a lot of development in terms of fiber optics. Now, fiber optics, actually, we are talking about the terahertz already. So until the time that they don't know how to give the proper name or designate for the certain range of the frequency, because you cannot differentiate clearly already after that, right? So here, what you can see column here is, this is a band of the frequency. This is the name of the frequency band. And then this will be the median. Median, that means initially for the low frequency, they use a typical higher, then come up with the coaxial cable. Then they are going to talk about the wireless. Then go higher. Yeah, we are talking about the optical fiber. All right, so these are the transmission median we are talking about. And what are the typical applications? So for example, very low frequency. So what actually we use the very low frequency communication typically for the naval communication. For example, the sonar and long range navigation communication purpose. So follow up, we will have different applications for it. Now, what actually we mostly interested will be the range from here, because this is a range we call very high frequency. You have a radio broadcasting, you have a TV broadcasting, and some of the telecommunication in terms of the cell phone network system will be in this range and this range. So typically, we are interested with the frequency in this band, all right? So you can see most of the application will be ranged from here. And after that, we are talking about the microwave. We're going to touch with that in chapters 7 later on, right? Then follow up, we're going to talk about the optical fiber communication, all right? So this will be the typical electromagnetic spectrum and allocation for the communication. All right, so the rest of the detail you can look through quickly. What is meant by the electromagnetic spectrum? That means there is a span of the frequency, so you can use it for the communication purpose. Frequency, it can be divided into different sections. For each section, we can serve for specific agency, or you provide the specific communication services. For example, the walkie-talkie actually is used by the policeman, will be from very high frequency. Typically, they are talking about the few kilohertz, will be arranged from of the frequency band for the walkie-talkie. All right. So when we are talking about the frequency, we arrange it in the band. So each band actually they occupy quite a small range of the frequency, right? So why we need to arrange it in such a way is because we want to avoid the interference. Because we have mentioned that if two signals with the same frequency, they overlap. And in this case here, there will be interference will be happen. Okay, so with this, I think we can try to proceed to the next page. We show you the formula. And this formula just now I show you already, right? So there is a relationship between the wavelength and the signal frequency. Then we can use it to calculate the wavelength very simply by using the simple formula. Okay, so last but not least, I try to show you the typical example, how we're going to deal with the problem related to the wavelength. So find the wavelength of the signal if you have 1150 megahertz. Okay, so if you have 430 megahertz, and this megahertz and then kilohertz, so what will be the wavelength? Okay, so this one, we will show you the different range of the frequency. Higher, lower. You try to see what are the changes. So for the first one, 1150 megahertz, you can try to calculate how much is the wavelength. So lambda is equal to C divided with frequency. And then we can see that 2 meters of the wavelength you will have if the frequency go such high. However, if your frequency is getting lower and lower, let's say 750 kilohertz. So you can do the simple calculations that the wavelength in this case here is out to 400 meter. So 400 meter is one round of the pattern, right? So that length of the antenna, can you design for that? So there is a good question for that one, right? So typically, what actually this question show you here is the frequency of the signal is actually justified. What would be the size of the antenna? How do we know that? Because this is related to the lambda you calculate according to the formula there. By finding that, you can see that higher of the frequency, shorter of your wavelength, and then shorter of your antenna. Lower of the frequency, then we can see that the lambda is getting bigger. And then 400 meters of the antenna size. So to me, I can't really build such a big size of the antenna, except for no purpose. So in order to save the cost, so typically we can try to use the high frequency for the signal transmission, because the size of the antenna, we can reduce it until minimum. Okay, so before we proceed, just have a spot check. just hold on now. I believe not. So what's wrong with MCMC? You want to know the full name, right? Okay, full name for the MCMC just now, I forgot the full name already. Yes, it's talking about the multimedia decommissioning. I forgot the full name already. So you can try to double check with the name, right? So it's the agency from the ministry. Okay, so before we proceed, I just try to show you one thing here. So just now we are talking about the lambda and the frequency, and then the lambda versus antenna size. All right, so that will be the two ideas here. So first one is talking about the formula, right? So we can use a formula to know what is the lambda if the frequency is given. And second one is what is the relationship between the lambda and the size of the antenna? Okay, so here I just quickly go through with you about the antenna design, right? So this one, you don't need to memorize now, right? Because this is additional information for you guys to understand, all right? So how we say that the lambda actually is the important parameter for the antenna design. So the size of the antenna is really depends on the lambda wavelength, right? So let's say you are using the dipole antenna, halfway dipole or halfway dipole for the communication to transmit the signal wirelessly. So this is the so-called halfway dipole antenna. So you will see there is something like the T, and then the length of the antenna from this side up to this one, the length actually is lambda divided by 2. So if lambda is 1 meter, so means that lambda by 2 is 0.5 meter. So from this end to the other end. Got it? All right. So here we are talking about the dipole antenna. The length of the dipole antenna or the size of the antenna is lambda by 2. How we measure it? We measure from here to here. Now, talking about the another type of the antenna is talking about the quarter wavelength antenna. Quarter wavelength antenna, we place the antenna something like this, and then the height here until the ground will be the length of the antenna. Is talking about lambda divided by 2, divided by 4. Okay, so again, you can see that this type of the antenna is depend on my lambda, right? So the lambda, typically, it will justify the size of the antenna. And in some case, with the antenna ditch, somebody have an Astro at home, so you can see the antenna ditch outside. So how is the size of the antenna? So typically, we are talking about the diameter, right? So diameter of the antenna, so means that, so this one is a diameter, right? Because antenna will be parabola. And then typically we try to measure the diameter of the ditch. And this diameter will be also related to the number of lambda, right? So depends on the type of the antenna ditch. So we have a different type. If you have a home fit in front of it, then my size of the antenna, D will be different formula from one another. So anybody interested, you can find it there by yourself. So what I'm trying to show you here is all the antenna we mentioned just now is the size is actually related to the lambda. So that's why in order to control the size of the antenna, you need to control the frequency. All right, so frequency of the signal in such a way that the size of the antenna can be manageable. Okay, so I think today up to here, actually I finished my lectures, right? So the rest of the time, we're going to discuss about the tutorial questions. Okay, yeah, Gabriel, MCNC mode, Malaysian mode communication and multimedia commission. All right, okay, very good. It's quite a long time. I forgot the name already. Yeah, may I request for 5 minutes break before we proceed? Yes, sure, go ahead. So we are going to continue around 2:20. All right, so I see you again. Short while. All right. So those who are here, you may be able to look through the tutorial questions. So 3 questions, we can actually solve it in this case. So question 1, 2, 3. So question 1 is talking about the explanation. So you try to explain that what will be the reasons you need to use the high frequency signal in the carrier in order to radiate your wireless signal, which is a radio frequency. Why we need to use a high frequency, all right? So there is a point. Then you try to justify your answer by using the simple calculations with the relevant data, showing that why you say so. Okay, so question number 2 is talking about the FM radio broadcasting. So as we all know that FM radio range arranged by ITU is 88 megahertz until 108 megahertz. However, in Malaysia, actually, the range is about 87 megahertz until 107 megahertz, if I'm not mistaken. So this is a range of the frequency we arrange for the FM radio broadcasting. Okay, so if this is a range of the frequency, and then we try to calculate how much is the frequency within the band here, and then what will be the highest and the lowest wavelength we might have for the frequency band. All right, so typically we can calculate for that. And third one is actually we are talking about the communication channel for specific service. For example, we are talking about the walkie-talkie. So if we have a one pair of communication, we have a walkie-talkie, let's say one pair, transmit and receive. So means that this walkie-talkie will use up certain range of the frequency. So typically, one walkie-talkie, they occupy one pair of walkie-talkie they will use up about 10 kilohertz of the signal frequency. All right, so typically the bandwidth in this case here for one channel is 10 kilohertz, right? So if you want to use a frequency for communication, then 10 kilohertz frequency will be used up. So we call it as a bandwidth, okay? So we try to calculate, let's say we have a median frequency band we have. So this is a range of the frequency band for the median frequency, right? So we try to calculate how many channels actually I can occupy for this band and also for this band, all right? So we try to calculate how many channels are available there for communication, okay? So we try to solve the problem here very quickly. So I try to give you about 10 minutes time. Try the questions 1 until 3, and then we're going to discuss the solutions for your guides. All right. Everybody finish? Hello? Not yet. All right. Okay. So let's try with questions. Let's say question number 1. Now, talking about the question number 1 is talking about the reasons why you need to use high frequency. I think this one is quite a common question already. So I believe everybody can answer. Anybody volunteer? No? Okay. Brian, can you answer the questions for the question 1? Hello, Brian, are you there? Nobody?
Yes, sir.
Okay, just a very quick answer. What is the reason why we have a high frequency signal to be used for the wireless signal?
To minimize the interference.
To minimize
The interference.
Okay, so just now we have one student, Brian, mentions that this one, we try to reduce the interference. That's why we use a high frequency. All right. So in this case here, do we agree with that? Why we use a high frequency? Because now you can see that at the back here, we are talking about the radiate as the wireless signal. So radio frequency is a wireless signal. So you need to relate the things here to the wireless signal. And interference is not really related to this question, isn't it? All right. So the reason why we use the modulation. First one, reduce the interference. Second one, Lion, what is the second reason? Ha ha ha. Lion, you still there?
Yes, yes.
Okay. So just now we say reduce the interference might not be suitable. So what would be the second reasons?
I'm not sure about that. I will find out.
Oh, you still try to find out,
Yeah, I'm still trying.
but actually it's inside your nose, right?
Yeah.
Okay, let me just ask next one. Fong Wing Hao. So what do you think? What will be the good reasons to use a high frequency in order to radiate your wireless signal?
So I didn't do. I just do the question only.
No, never mind. You just roughly explain your answer. What would be the reason? Wayne Hao.
I don't know.
Don't know? Okay, so remember, I will go back again for those not yet answered my question. Okay, Jared.
Yes.
Okay, so what would be the good reasons for that?
Using high frequency,
Yes.
so that we can send the signal to longer distance. It is difficult to send low frequency signals.
Okay, so explain the reason why we use a high frequency signal. All right, high frequency for the signal and a carrier in order to radiate the wireless signal, right? So your answer is, so we use a high frequency so that it will be radiate, it will be able to transmit easily, right?
Yes.
Okay, so the answer is not really so precise. Okay, let's try somebody else again. Gilbert. So what do you think? Gilbert? Transmission purposes. No, really? Okay, some more. Ivy? Ivy's here. Ivy, you there?
Yes.
So what would be the reason? Robin say convert the information into suitable signal for the communication. Not really precisely again. Okay, how about Ivy? Lin Salong say to reduce the antenna size. Correct. So this is a second reason why we use the modulation, isn't it? So the first one is reduce the interference. Second one is the size of the antenna can be manageable, right? So that is the reason why we use modulation. Manageable means that the size of the antenna is getting smaller, right? So you can solve the problem in this case. Right now, for the first part of the question, first question in this case here is actually your focus to present the relevant data, why the low frequency is not suitable to radiate the wireless signal, right? And you need to do the simple calculations, present the typical data. For example, the frequency, you use the low frequency, and then you try to show that the wavelength is getting bigger. And then how this wavelength is related to the size of the antenna, right? Then you explain for it. And that is actually what we need to present for this question. Okay, so here I try to quickly show you the sample solutions as a reference. Now, for the answer here, typically you can explain it by using the simple calculation of the wavelength for the signal you transmit by using the formula here. And then you try to use the practical data. For example, you try to show the frequency 20 Hertz, 20 kilohertz, and then you are going to get the different wavelength, right? So from there, you can see that when the frequency is getting higher, and then the wavelength is getting shorter, then the size of the antenna can be manageable. All right, so I repeat, for this type of the equation, there is no A to Z in order, so you can present your answer according to what you want. So basically, what we want to present here is tell the audience that your lambda is an important part you need to control, because this will justify the size of the antenna. So that's why we need to use the high frequency to radiate the wireless signal. All right, so you can use the formula here to do the calculation. And then you can present the things here by using the relevant data. For example, you try to show two signals, one lower, one higher. So you can see that the lower frequency, longer wavelength. The size of the antenna, very big. However, if the frequency go higher, either is 20 kilohertz or 20 megahertz or 20 gigahertz. So you will see that the lambda size is getting smaller. So means that frequency go higher, the antenna length got shorter. The size of the antenna can be manageable, right? So last but not least, you can further explain that the typical antenna length or the size when we design for it. So typically will be at least lambda divided by 4. So that means quarter wavelength. So just now we show you the quarter wavelength antenna length. So that will be the size of the antenna able to relate to your lambda, right? So let's say the lambda is given this one, then the size of the quarter wavelength antenna is 15 times 10 power 6 divided by 4 meter, all right? So that is the typical answer you can present it in this way. All right, so you can later on, you can try to look through the video clip, and you can stop or pause the picture, and then you can copy down the answer without any problem. So okay, everybody? Do I need to spend the time here for you to copy down? Okay, very good. Okay, now we try to see the second question. This one I would like to get some answer from your guy. Okay, so now we look at the second question. Now there will be the given, roving, okay, the bandwidth 20 megahertz, correct? And then the maximum wavelength 3.4 meter for the minimum, and then 3.41, all right? So 3.41 for the minimum wavelength, maximum wavelength, and then the minimum wavelength is 2.78, all right, by using the formula. Do you agree? Okay, very good. We have an answer from Robin here. Okay, never mind. I just quickly show you what will be the answer. Okay, so what actually we have for the first question here is there will be the given range of the frequency. So if you try to plot your frequency range, so this one is talking about 88 megahertz, and this one is talking about 108 megahertz. Okay, so what is the range of the frequency here is talking about the bandwidth. All right, so in order to calculate the bandwidth, you just try to subtract 108 with 88 megahertz, then you will get 20. All right, so in order to calculate your maximum wavelength and the minimum wavelength, so we are going to use the lower limit of the frequency, then you will get the maximum limit for the wavelength. However, to get the another end of the wavelength, so maximum limit of the frequency, you will get the lower limit of the wavelength. All right, so you can try to use the formula to do the calculation. This is the answer what I get. All right, so but here, okay, so this is actually what we are talking about. So in order to talk about the communication channel, right? So this is actually one channel for the communication. Okay, so for one channel, let's say we have 10 kilohertz. So if you have a whole range of the frequency here, so how many channels I can figure in for the communication? That is actually the questions they are asking. Okay, so for the first case, we will have the medium frequency range, and also the second case, high frequency range. So let's say the communication channel, one channel, just now we show you that there will be the 10 kilometer bandwidth we'll be using. So let's say this walkie-talkie, they use 10 kilohertz for frequency for the communication. So for one channel, 10 kilohertz. So for the medium frequency, these are the frequency range available for me to do the communication. So how many channels actually I can figure in this case? Anybody have an answer? Medium frequency, how many channels do we have? Two, 7, 0. Are you sure? Any other answer? Yeah, medium frequency 270, high frequency 2700. Yeah. Okay, if 270 is everybody agree? 270 lah. Right. Okay, now here I try to show you the answer. So what we have here is for the medium frequency, the bandwidth available is this one. All right. So this is the whole range of the frequency. And then for 1 kilohertz is occupied the small range. So we're going to calculate that this bandwidth, the range, so how many channels I can figure in. So all you need to do here is the bandwidth divide with 1 channel bandwidth. There will be the total number of channels. So you divide from that, then you can see that the answer is 270. However, if you are talking about the high frequency band, the bandwidth available for the communication is bigger. And then you can see that the number of channels actually will be bigger as well. Okay, so you can try to copy down the answer later on after you snapshot the picture. Okay, so last but not least, I just try to show you the picture here, right? So what actually we have for picture is the practical example of the channel for the communication. Now, in fact, for the actual communication, so one channel is not really close with another channel one by one, right? So you can see that we are actually separate one channel with the another channel by using the gap band. Now, why we have a gap band in this case here, in between the channel? The reason is because when we design the communication devices, so we specify that all the signal for the communication, the frequency will be confined within the range here. For example, we try to confine the frequency, lower limit frequency and the upper limit frequency in between these two limits. But however, when we design the communication device, now because of the deviation of the component, or maybe the design is not really good enough, perform better, and the signal frequency, initially what we expect here is the signal frequency will be around here. But however, due to the deviation or drift of the component, my frequency will be going something like this. So what happened here is you can see that this one, and this one, we will call it as the noise to other channel, because this signal actually is belong to channel 1, not other channel, right? So we have a spray over the signal in terms of the frequency. It might be happen in this case. So in order to prevent this type of the problem and then interfere with other channel, so we will have a gap band. So when the signal is sprayed to the gap band, and then this gap band actually is something like the allowance, then it won't affect the other channel. So we can save a lot of problems in terms of the communication by using the gap band. All right. Now, when we talk about the proper allocation of the frequency for the communication, there will be the gap band we put in. So once we put in the gap band, so means that the number of channels we calculate previously will be less. So will be less than 2,700. So typically we are talking about not 200, 2,700, but we are talking about typically 2,000 only instead of a 2,700. All right. So this is try to explain the actual allocation of the 50 for the communication. There will be the inclusions of the guideband in this case. Why we do so is because we try to reduce the interference to the minimum. All right. So with this, I think that's all for today, right? So let's go through the last round. Anybody have typical questions you want to ask before we finish our lecture here? Just go around. Anybody have questions? No. Wow. The rest of the people very silent, huh? So next time I should start with the name at the back first, especially Yao, the Yao, huh? Okay, and okay. Yeah, can you show the sample solution for what? Sorry, can you show the sample solution for question number 1? Hey, just now I show you the question for number 1 already, right? All right. Okay, so this is a simple solution for number 1. Now, don't worry about the simple solution because you have an archive video already. So if you miss out anything, you actually can rewind, right? So you can rewind and post the picture. So you can copy as long as you are happy. Okay, right? So, yeah, for you to snapshot later on, huh? Okay, so no more questions? If no more questions, I think it's good. It's a Friday already. So tomorrow is a weekend. Have a nice weekend. Yes, Xia Yu, what's the question? When is our next class? Should be on Thursday, right? Is it on Monday? I don't have a timetable for Monday.